right, this is number 10 from the section 2.8 notes. We're looking at an air traffic controller that spots two airplanes at the same altitude converging to a point as they fly at right angles to each other. Okay, so I will say the one on the homework is actually more simplistic than this now. It is just a single airplane. So I am going to do this one just because I promised it for you guys, but it is not as difficult as this one if you look at the one on homework. It's more like the right triangles we did in class already. So we've got our A1, which is airplane 1, and we've got A2. I'm trying to draw these at the same altitude, but it's kind of hard to draw a straight line with this pen thing. They are currently, it tells us at some point how far apart they are from each other. No, it doesn't. We'll have to find that. Okay, so, but they're flying towards each other at a right angle. So imagine them both heading towards this path, and this is a right angle. Okay, so we have the first airplane. We're going to call this side of the triangle X, this side Y, and we'll call this side Z. When we look at this one, it says one airplane is 150 miles. So that's going to be this one. So X is going to be 150 miles from the point of convergence. So I'll write down here, this is going to be the point. If they continued on this path, this is where they would hit each other or meet. And then the other one is 200 miles from the point of convergence. And we have these two speeds. Now, since their distance and speed, we are traveling towards each other, we're going to be decreasing the sides of this triangle as we go. So we're going to be using that the speeds are, they're changing in a negative direction for this. So we have dx dt is going to be negative 450 miles per hour. And then dy dt, I'm just looking up at the problem, is going to be negative 600 miles per hour. And you could write your units on here. This one's miles per hour, miles per hour. This is in miles, and this is also in miles. Okay, what we don't know is what I was just talking about. We don't know the original distance they were away from each other at that same altitude. So we're going to use our Pythagorean theorem, x squared plus y squared equals z squared for that moment in time to find what the z was. So we had 150 squared plus 200 squared. These are the sides of the triangle, equals z squared. So when we work this out, get my calculator. We have 150 squared is 22500. And 200 squared should be 400,000, I believe. Yep, so, oh, 40,000, sorry. Too many zeros. 40,000, so 4 zeros. And then we'll have to add those together and take the square root. So if we add them together, we get 62,500. If you take the square root of that, you're going to get our length of what was their original distance away from each other at that altitude, which is 250. Okay, so 250 miles. 250 miles. The question for part A says, at what rate is the distance between the two planes changing? So we're looking for the distance between the two planes. We're going to imagine as these sides shrink, we're going to be measuring that hypotenuse, and it will be shrinking as well. So I'm expecting this to come out negative for the velocity. So when we look at this, we're going to do our derivative of our formula for that Pythagorean theorem. So that'll be, remember, with respect to t, this will be 2x dx dt plus 2y dy dt, and it equals 2z dz dt, which is the one we're solving for. We know everything except for dz dt. So 2 times 150 miles times the negative 450 plus 2 times, we have the 200 miles and the negative 600 equals 2 times 250 dz dt. So if we work this first part out, that's negative 135,000. So that's negative 135,000. The second one comes out to a negative 240,000. And then this is 500 dz dt. We add these two, they're together, they're going to get more negative because they're both negative. So that'd be negative 375,000 equals 500 dz dt. Divide both sides by 500, you get negative 750. And again, this is the speed, the rate at which the distance between the planes is changing. It's changing at negative 750 miles per hour. So that's the change. So again, why it has to be negative is because that distance will be shrinking on all three sides. All three sides are moving in this problem. So we had the other problems last time where we had like one fixed side of the triangle, like the ladder, or we had one of them was like the winch to the bottom of the pier. Those were fixed sides. They couldn't change their size. But here we're having all the stuff is converging together. So everything is losing distance per hour. So that is the rate. So that's the first part. So dz dt is negative 750 miles lost per hour. Okay. Now, obviously, the next question logically would be, well, how much time would that error controller have to get them planes on a different path so that they're not going to meet at that point of convergence? Because that's usually what their job is to make sure everybody's in their own space. So this is really dealing with the formula for distance. So time has to do with distance equals rate times time. Okay. Now you can take either of the two planes. I took the one that was 150 miles away from the point of convergence, and its rate was the 450. Now you could put that in as negative if you want to, but you'd have to realize time can't be negative. So when we're solving for this part, you really don't think of it as positive or negative. You're just putting in the speed. So this is 450 t. If you divide that over, you're going to get t is 1/3 of an hour. Okay, because you get 150 divided by 450. So if you reduce that fraction, you get 1/3 of an hour. Now, you know, if you want to know what that is, you could do 1/3 times 60. So a way to answer that in an easier format maybe would be 20 minutes. So you could say 1/3 of an hour, or you could say 20 minutes, whichever makes more sense if you're telling someone this. So they have essentially, so notice they're not going to have a full hour. These planes weren't that far apart. They're going to have 1/3 of the hour to get them on a different course. Okay. And if you think about it, that makes sense because 1/3 of 750 would have been the 250. So we would have shrunk the distance at that altitude down to 0. So they would have met at that point of convergence by then. So we have 1/3 of the hour to get them on a different course so they don't meet, which is, like I said, roughly 20 minutes. And I just multiplied 1/3 by 60 for to convert that to minutes. Okay, so like I said, this one is no longer in the homework. I did double check that, but there is one in the homework that talks about an air traffic controller. It is more set up like the other two types we did with the Pythagorean theorem. So just be aware of that. It has kind of the singular plane instead of two planes moving towards each other at the whole time. Okay, and that should be good. So everything else we did in class. So just make sure you bring all your questions on Wednesday for the review packet you picked up today. And let me know which ones you want to do first. That'll be our first order of business on Wednesday, is just tell me which questions from the review packet are the most concerning. Make sure you've turned in all your other assignments digitally, anything that you haven't turned in to me yet, so I can get those graded. And I look forward to seeing you guys on Wednesday.